So this is about using Captum and Fiddler together to improve AI model understanding.
Captum is a generic and unified model interpretability library that aims to help model developers to better understand their model internals and the predictions. So we support various different types of models, including multi-model models. And that means that model inputs can be both dense and sparse features coming from various different sources. So the open source version of Captum library currently offers scalable implementations of a number of gradient and perturbation-based attribution algorithms. And we also added a couple evaluation metrics. The library is designed to be used both for research and production.
We both saw kind of an internal and external opportunity. And so we really started working on this about just a little under 2 years ago. And from an internal perspective, we see just a really strong need from our developers. And that's both on the product side, which are teams that are really trying to solve kind of very, very specific problems within products. And then also from our applied researchers that are really working on kind of new architectures and new capabilities. And what we've seen is essentially that the models have gotten more complex, but also the problem areas have gotten complex. And one of the main things that a lot of the teams really work on is content understanding. So if you think about a lot of the work that we do, it's really about trying to understand a specific like post and essentially how to classify it in some way.
When we talk to customers, a lot of the most interesting and most valuable use cases to like, you know, the organizations out there in the world of machine learning are very like, I don't know, they don't look like the simple, you know, tabular classifier examples that you see in kind of like the academic literature. It's much more like, here's a garbage can full of like text and an image and a bunch of dense features. And so, you know, having a robust framework that addresses that, I think is just super important.
Well, Fiddlers' mission, to put it like very succinctly, is to bring trust into AI. And we believe that can only be done if it's AI is done in a responsible way, and also ensures for AI being inclusive and accountable. So a lot of big words there, but yeah, I think the gist of it, of AI being responsible, can only happen when humans are in full control of the AI agent. For complex deep models, especially, one of the core challenges to explain them is to hook into those models at the appropriate points, so that we can like properly probe their behavior. And that is easier said than done because there are a plethora of frameworks out there. There's many, within those frameworks, there's a lot of flexibility. So you can build the same model in many different ways. You can use different naming conventions. So getting these hooks into the model is a complex task. And for us to be able to serve any model out there, we need a platform and a contract and an interface that is easily accessible to users and which they can make sense of. It's not feasible for us to manually sit down with every customer and help them import their model. So this interface that Captum has provided, for at least for PyTorch users, they have defined and standardized that interface. And being an open source library by Facebook, we know that they will support it for a while. So that gives us the confidence of using it to extend its benefits to our own users. We help our customers understand what we really need, and then it makes model ingestion for them a lot easier.
So with the growth of PyTorch community, we realized that it is essential to have tools and algorithms that can help to monitor and debug the model. They have to be easy to use, they have to be solid, and they have to be generic.
Certainly when we were first developing Captum, you know, our goals were really around helping developers build better models. And that was very much around model understanding really in the authoring phase. So authoring, exploration, evaluation. And so what's really been great about this is that it's, you know, kind of pushed us to really think a little bit more about kind of production and inference time use cases, and also to kind of expand the set of stakeholders that we're thinking about. In a lot of the areas that we work, they're generally very dynamic or kind of adversarial spaces. And so our ability to not only detect when model performance is declining in inference time, but being able to like diagnose that very, very quickly, understand which specific signals are the ones that are missing, Like, for example, there might be a new term or a new piece of slang that people are using, or people may have found a new obfuscation method with images. And so being able to detect those things very, very quickly and in figuring out how to essentially augment our data sets is something that is really critical. And so being able to understand large swings in attribution and how that might be a signal that some upstream model has an issue of some kind is really critical to us. And so I think this partnership has really kind of helped us in terms of kind of thinking in those directions.
Let's say a sort of data studio where you can analyze the data and model together, which we call analyze. And we were able to find out, okay, what are the main reason for that is that in the data set, women appears in toxic sentences way more than it does in non-toxic as compared to men. So that ability of attributions, of having attributions, plus having a product which helps you do further debugging and analysis and query your data and model together. That's when, that was a really great example of the synergies that Fiddler and Captum bring to each other.
One thing that we've talked about in prior conversations is how you extend these tools into, complex machine learning ecosystems. I've already kind of brought up all of these, this sort of my experience with customer use cases that are, unusual and exotic. But it's not just the models, right? There's also these complex distributed computing infrastructure issues that you encounter when somebody shows you how their systems are working.
So one is the complexity of the ecosystem itself, right? So there are a lot of these models, and they do interact in very complex ways. They're also being updated, and owned by different teams at kind of different cadences and things like that. And so being able to, from a model understanding perspective, being able to kind of zoom in and zoom out in terms of either looking at the entire inference graph and looking at the raw inputs and kind of what the output happens across the entire graph is important. And then being able to zoom in on specific areas is really important. And so one of the things that makes that difficult is that in certain cases, these models really can be kind of stitched together into one graph. In certain cases, some of these things are being done asynchronously, and so you can't really do that. And so that's really kind of an area of research that we're interested in.
Yeah, I think as Carlos mentioned, it is important to have tools to be able to both zoom in into a specific model and specific layer and deep diver to understand what's going on, and also to look at the bigger picture.
The possibility of learning to explain. So simply what it means is, let's say you have a very complex system. Let's say for fraud detection, you have a bunch of human rules. You have different models, which there's a model which takes in text data and gives out an embedding. There's some other data that's coming in tabular data. Just imagine there are multiple models that plug in and out of the system in many ways. And there are if statements, like I said, there is maybe at the end, there is another linear head, which takes all these inputs from these models and the human rules and makes a final decision. So you could have any arbitrarily complex system. And to be honest, I think that's more than what we're seeing. Like in production, a model is not one pickled object, or it's more a system of models and code, which comes together to take in an input and finally give a result. So in that sense, how do you understand such a system, right? Do you understand each model by parts? Yes, that could help, but how do you tally together everything? Like how do you weave it all together?